Okay, so in this section, we've been talking about different bits and pieces of information that will help us graph a polynomial function. Now, to be really honest, most polynomial functions would be very difficult to graph by hand. So we're going to give you hopefully some nice clean ones that aren't too bad to work with, but we want you to be able to do a rough sketch by hand, okay? If you want beautiful graphs, you get a graphing utility calculator or a program that'll do it. Desmos, I don't know if I've talked about that in here, but Desmos is a program. You can go online, it's free. It'll graph you beautiful polynomial functions. Okay. And all you have to do is type it in. But we want you to understand the concepts that are going on with graphing a polynomial function. So here's the strategy. There's 5 steps. So the first thing is leading coefficient test. That's to determine end behavior. You got to know which way it's going. So that's really important. So we're going to be graphing in example 9 here. We're going to graph this function. So n is even, and the leading coefficient is greater than 0. So that means it's going to be having n behavior up to the right and up to the left. Okay. The next thing is to find the x-intercepts or the zeros. Find those zeros. You want to do their multiplicities and their behavior. Okay, so for this example, I would have to graph it. Factor it. I'm setting it equal to 0 to find the zeros, and I get x squared minus 1 times x squared minus 1. You can just trust me on the factoring there, or think about it for a minute. Those are the difference of squares, so I get x plus 1, x minus 1, x plus 1, x minus 1. Now, if I really want to talk about multiplicities and behavior, then I'm going to say it's x plus 1 squared and x minus 1 squared. Now, I'm going to drop the 0 and write with my notation with the function. That is how the function graphs, okay? That was probably really fast. So go back, rewind it, and watch that part again. But in factoring the function, I'm going to set it to 0. I haven't actually found the zeros yet, but I will. So the zeros are negative 1 and 1. Those are the zeros, okay? What does that tell me? It tells me that negative 1, it's crossing the x-axis. And at 1, it's crossing the x-axis. Okay, so I'm probably going to have a kind of a little skinny graph here. Okay, those are the zeros. What are the multiplicities? The multiplicity of negative 1, that comes from this factor, and it has a multiplicity of 2. And then this one comes from that factor. The 1 comes from that factor. It also has a multiplicity of 2. So the behavior is it's going to bounce. Or touch. You can put touch. Okay, at both of those. All right. So what was our end behavior? I got to go back up and look. The end behavior says it's going up to the left and up to the right. So I know now it's going to come down, it's going to bounce and do something, and then come back down and bounce and go back up. Okay, so that's the general idea. We're not quite done though with our strategy here, but we've got a really good start. We want to know the y-intercept. So step 3, how do you find the y-intercept? It's f of 0. So if you plugged in 0 into the original function, so that's going to be 0, that's going to be 0, you're just going to get 1. What does that mean? It means that the y-intercept is 0, 1. That is the y-intercept. Okay. So that's, I know it's going to go through there. Okay, then I just think I have one more thing here. Oh, 2 more things. Symmetry. Okay, now let's talk about symmetry. We haven't talked a lot about that. But our function says x to the 4th minus 2x squared plus 1. If this is an even function, then it's symmetric about the y-axis. And to be really honest, that's the time I find it useful, is if it's even. So let me put in f of negative x, and let's see what we get. And we'll know if it's an even function. and that's going to be x to the fourth minus 2x squared plus 1. So it's the same thing. So this is an even function. Oops, even function. And that means it's symmetric with respect to or about the y-axis. That means for every point on the left of the y-axis, there's one on the right of the y-axis. Okay, that's enough for me to graph it. How many turning points can I have? The number of turning points I can have, turning points, at most is 3. Okay, so that really helps me out. Now, if I wanted to find more points, I could. So over here, if I wanted to find like f of 2, I already know what f of 1 is, but if I wanted to find f of 2, I would go 2 to the fourth minus 2 to the fourth minus 2 times 2 squared plus 1. So that's 16 minus 4 times 2 is 8 plus 1. So I get what, 9? Okay, that's pretty up there on my little piece of graph paper. 2, 9, way up here. Now, the good news is I know there's one, because it's even, I know there's one on the other side at negative 2, 9. I know there's a point there. And then I can draw this. I just try to draw it as best I can. I know it's going to bounce there. I know it's going to go through there. It's going to bounce. And it looks something like that. It's a very rough sketch. It doesn't have more than 3 turning points. It bounced where it was supposed to bounce, and it went through the y-intercept. And we got lucky. This wasn't a larger number there, so we were able to graph it. But that's the general strategy of how to graph polynomial function. And we just try to do our best.